So, hello everyone. Oh, you have to excuse my croaky voice. It's been a rough couple of days with a beer. So welcome to Why Do I Hate Unit Testing, but everyone else seems to love it. We'll do the quick bio. There you go, really quick. If you really want to read it, you can grab the slides afterwards, but it's not very important. So why do we write unit tests? Now, there's plenty of reasons for doing this, but my main one really is doing manual checking your code is really boring, really repetitive. Ugh. You don't want to do that. And there's time spent doing better things. But one of the things about unit tests is they're supposed to make our life easier rather than harder. But what I see is like a lot of people make some really, really simple mistakes that you don't know you're making that actually makes your life harder. So you end up with very brittle, unstable test suites. And what you end up with is your boss is saying, how long is this going to take? You're like, half a day. And then you're like, oh no, but I've got to fix all these tests that are broken, so actually it's going to take 2 days. And you're in situations where everyone's going, I don't want to fix those sodding tests anymore. You know, I want to do something else. And worst case is you just start turning them off. So what I want to talk to you about today is just some of the things I've learned over the last decade or so I've made all these mistakes. I'll put my hand up and say that. I've interviewed a lot of people, trained a lot of people, and everyone does the same thing. So there's a lot of slides to get through. Just get yourself kind of strapped in and get ready. So the first one is, let's talk about test naming. So let's see a show of hands, anyone in here who's ever seen or written a test called this. Yes. Oh, more than I thought. I actually did a Google search for this, for public void test 1, and there are 250,000 hits for that. Some of them are valid. If you look at the test for JMock, that's got the 1 constructor in, so that's valid there, but most of them are generally not. So the big thing, I'm guessing everyone knows, is you don't know what's testing anything here. You don't call a class 1, you don't call a method 1. Why do you call a test 1? It doesn't make sense. Now this example, this is kind of like the usual kind of thing you see is someone's realized I'm testing the customer DAO and I'm testing the save customer method. So that's where I focus my test names around. Again, this is still not very good at all. So you've got a bug that comes in and someone's like, I need to know why, when I save a customer, something hasn't happened. You go, okay, let me check the test suite. Don't know which one it is. I have no idea what I'm looking for there. And these things are part of the public API. Never part of a public API. So these things can be as long as you want them to be. We kind of tie ourselves into normal thinking about code and kind of shorter method names. And if you look at the JDK API, you're looking at things like integer.parseInt. That tells you you're going to parse something in an integer. Socket.open, I'm going to open a socket. So why don't we write our test names in the same way? So one of the things I like to do is ignore the fact that I'm testing this class and I'm testing this method. That isn't very important, and it's also not very resilient to refactoring either. So in this example here is my save customer method. I refactor the name of that method now. My tests are now pointing at something else. They're not giving me the information I need. So what I prefer is something a bit like this. So what I'm doing is got a combination of action for the class name and behavior on my test names. So now when someone says, you've saved something and the action hasn't happened, I can be like, aha, there's something wrong in the raises save event stuff going on there. So it lets you kind of focus in really, really easily and quickly on what you want to know. And one thing all JUnit documentation tells us is tests become executable documentation. It's a good thing. Don't write documentation anymore. It's executable. That is not documentation. This is documentation. It's really getting to the heart of what you want. And I was talking to Rob and Malcolm about this on Monday night, and they did remind me of the old phrase, there are only really 2 hard problems in computer science: cache invalidation and naming. Following this approach, naming is now no longer a problem because you're writing something. You know what your action you're going to take is. You know what your behavior is. Embody that into your test name. Did anyone go to Rob's talk this morning on groovy testing with Spock? Like, that was awesome. Like, you don't even care about method names anymore. They become unimportant. So here we have, so get yourself a naming scheme. I don't really care what it is. You can pick your own, but get one, follow it, and really focus your test names on behavior. So what's next? Verification. So what this is kind of always seeing your test fail. Now, if you're doing TDD, anyone do TDD? Yeah, everyone, half the room, yeah. So I've seen a lot of people say they do TDD, and one of the tenets of TDD is always see your test fail. Now, I can't tell you the number of times I've seen people who do TDD and bang out a whole suite of tests and then just watch them all pass and implement the code. You're not doing TDD. And if you never see test fail, you don't know they work. If you're doing test after, it's kind of a little bit harder. But what you can do there is I like to just go and break my production code, write the test, break the code, see my test fail, come back, fix production code. So this is a code example now from legacy code base where I work. So who knows what this is testing? Can you show our hands there? Who knows what this is testing? A couple of people. This tests absolutely nothing at all. This is like worse than no test because you think this is going to work and your code coverage rates are going to go up because I'm executing some code, just never actually testing anything. And why that is because we run the code and then we print the results out. Fantastic, whoever wrote this, yay, thank you for that. I'm going to have to go and check it by hand. So your tests always need an assertion. It's a guaranteed thing. Always see that test fail and fail for the right reason. I think there's like the thing you need to follow there is arrange, act, assert. Set up your test, perform an action, assert something happened. So let's change that now. Let's add in an assertion. So we've got an assertion now. It's a rubbish assertion, but something a lot of people do. Now I can run this test now and see it fail. Yay, it fails. But you need to see it fail for the right reason. You'll see a lot of people, you'll skip your diagnostic stack. You'll see red bar, awesome, fails, I'm going to move on. Now the problem with this code is this test will fail, but for the wrong reason. So if you look at the first line, that's going to throw a null pointer exception. And you've never even executed your production code here, never mind hit your assertion. So always read your diagnostics. Now this is going to give us really rubbish diagnostics. Assert true should only ever be used when you're checking a Boolean value, never any other time. So we need some more information out of this. And a go-to place I see for a lot of people is I'm going to add the exception, the assertion method into there. So I'll just show you. So there we go. I'll add my little bit of text in there. I'm not doing this. This is boring. This is duplication. This is typing. This can get out of sync with your actual tests. And you don't need to do this. If you're doing this at all, stop. I can't even remember the last time I had to do this. Your test runner, JUnit, TestNG, they will take care of this for you. So swap that out for something like this. So now I've got one value, you're telling me I've got another one, I'm going to get some nicer diagnostics here. So if this comes back as I only get one result in my collection here, it's going to say, you told me I had two, I've only got one. Brilliant. But diagnostics are still really rubbish here, because if you get this, how are you going to figure out what was wrong? You're going to get in the debugger, you're going to throw some print statements in. Now you're back to doing things manually, and I hate doing anything manually. So you can make it a little bit better. Typical thing to see here is, I'm going to go and poke around inside the collection here. I'm going to check that this works properly. And for a list, you kind of go, it's okay, it works, it's not great. But I change this to an unordered collection. This is just not going to work anymore. You're into all kinds of hacks in your tests to basically turn it from an ordered collection or an unordered collection to an ordered collection so you can take things. It's not very good. Wouldn't it be nice if something did that for us? So Hamcrest. I would hope everyone is familiar with Hamcrest, but I do see a lot of people who've never even heard of it. I can see a few people writing notes now. So Hamcrest had lots of really good stuff built in to help you with this. So it will do things like, I want a number greater than 10, or I want a number less than 20. And you can stick them together and say, I want a number that's greater than 10 and less than 20. And it will produce really good diagnostics for you. So in this example, it's got one that checks collections for you. So here we go. Collapse it down to one line. score, less typing. It's got our size checking, it's got our content checking. Everything's wrapped up into one single concept. And the best thing about this is, when this fails, this is going to pop up and say, you told me I had these 2 items in, but you only gave me one of them. No debugging, no printing, it's straight in there. I know exactly what the problem is. So for this section, so always see your test fail for the right reason as well. And you want some really rich diagnostics. You never want to mess around with your tests after they've been written. You want them to tell you what went wrong. And don't manually verify your code. Play foosball instead. So I just have some water. So, what do you test? Now my colleague down the front here, here's a sticker on his monitor at work, which is this. Test all the things. Now who tests everything? Anybody. One person, Rob. Okay. So why don't you test everything? The usual reason for this is that code is too simple to break. This is what I hear. So here's some code. And this is quite simple. Take an array of strings, join them together with a comma, send the output. Now this was real code at a famous 3-letter bank I used to work for quite a few years ago. So ignore the fact that you shouldn't write this code in the first place. It's in the Commons library. But this code has got a bit of a performance problem. So you can see in the middle here, given a large enough array coming in here, you're going to hit memory problems and performance problems. You think, maybe not. Unfortunately, for this particular company, this actually happened at 3 a.m. Now, I don't know about the rest of you guys, but at 3 a.m., I am not working my best. So it got fixed. Here we go, fix. String buffer, everybody knows how to fix it like that. But unfortunately, this code has a slight problem. It performs better, but it's now got a trailing comma on it. Now, this code didn't have any tests on it because it was too simple to break. Fortunately, it broke. So instead of being told 2 seconds later, you've broke this code, fix it, what it was, committed it, it got deployed, phone call at 4 a.m., your code still doesn't work. Can you come and fix it? So most things aren't too simple to break. So really test everything. But what does that mean? It doesn't mean this. I can see a few people chuckling there. This is real code. I have seen this happen. Yeah. This is never going to fail. This is never, ever going to fail. When we said, see your test fail, you cannot make this fail in any way, shape, or form. This, also seen this out in the wild, this is also never going to break. When I say never, it's a little joke for the older members of the crowd there. So in both these scenarios, what you're doing is you're testing the JVM. Don't test a JVM, you're wasting your time. In fact, don't ever test anybody else's code. If you didn't write it, you don't care. You're just wasting time, and the foosball table is calling your name. Get to it. So another step is don't type code you don't need. So here's an example here. And it's just like, I see this more often than I should, is you've got some tests, you wrap them in a try-catch block, and then you call fail. It's like, you don't need to do this. Like your test runner will do this for you. Swap it out. Let it handle it for you. There's a couple of guys down the front chuckling. Can't believe how many times I've seen that. Sorry, I'm missing what I'm on to next. Okay. So next thing is like, who uses code coverage? Quite a few people. Yeah, it's very popular now, isn't it? Very cool. We can see how many tests we've got done. Code coverage only tells you one thing only. How much of your code isn't tested. It never tells you how much of your code is tested. Now, one of the things you see, and you see a lot of this, like blog posts and a lot on daily, what the fuck, actually is on there, is my boss has told me I've got to raise my coverage rates. Yes. So what do? You go and start writing tests for getters and setters. Remember at the beginning when we said, naming your tests and how you're going to name tests. How are you going to name this test? Are you going to call this test like assert that or test that my constructor works? Okay? No. This is not going to fail either. This is never going to fail. If you find yourself doing this, stop doing this as well. In fact, this whole session should have been called Things You Can Stop Doing. These things want to be tested. You want to know your getters and your setters do work, but not here. You want something functional in another class using this, or if this class makes use of those variables, test that as part of something else. This is not behavior, this is implementation, and you don't want to test implementation. I've included the setter-based one at the bottom for the strange people around that still mutate their objects. So another one here is testing things that if they break, you actually don't care. Exception handling is definitely the big one. Exception handling and logging are the two things you get in this area. And what you see here is like you come along, you go and change an exception message because you want some more data, you want less data, whatever you want. And now you've got to fix like a whole bunch of tests. And you think, well, I don't care. Is anyone ever going to see this? Is this part of an API I'm exposing to anyone? And if it's not, just stop. Get rid of this test completely. Well, not quite. What I would do for these is make your production code nicer. Introduce a specific exception telling you what's going on here. Something like this. So now your production code is going to be a lot better because your clients of your code can respond to what you want more, and we've reduced boilerplate, less typing again. So there's kind of like a few things you can just basically stop doing, really. But what about testing too much in one go? So here's something I dragged off the internet. This is a single test method. Oh, everyone's laughing now. But this is actually from the GWT codebase. So this is not being produced by, rubbish people. These are really smart people doing this. And I think the guy who wrote this also knew that he needed to break this up because he put comments in it and told you what all the logical blocks were. So, and he's almost got test names here. So if you're writing tests that are too big, break them up and think about your behavior. That's quite a big, everyone's laughing, that's quite a big example. But what really is too much? Let's take something a bit smaller. So here I've got some code, and this is kind of like a good interview thing. I think we had up on the LJC board today about doing some palindrome stuff, so everyone should know what's going on here. Now, who thinks this is too much in one go? Not so many people now. So, first of all, look at our naming again. We're focused on the method we're calling and their action, but we're not focused on our behavior. But the biggest problem is, let's say the first line fails. So we're passing in a null, that fails. We've now got no other bits of information about what failed. If everything failed, we've got a serious problem. If nothing else fails, we know it's just our null checking that's the problem. So we can use this to dive into problems really, really quickly and not spend time messing around trying to figure out what's going on. So with this, I would split this up into 4 distinct test methods, like this. See, they're all very, very small now, very nice, very concise. But again, the documentation is, on the left-hand side, it's kind of, the first 3 are very obvious what's going on, but the last one isn't so much. But now we've pulled it out to a separate method here, is we can see what it's telling us. Our documentation is saying now, I don't care about case when I'm looking for palindromes now. And if the inverse was true, you can embody that in your documentation again to say, we actually do care. So naming is, I'll keep coming back to the naming, it's kind of the theme for the whole thing. I was trying to rob eyes today, it's much undervalued. Everyone just kind of seems to ram something in, but it can really guide what it is you're trying to get to and make your tests so much better. In fact, when you've split your stuff up like this, one rule I like to find is I'm virtually never changing my test methods. What I'm doing is I'm adding test methods, I'm removing test methods, but I'm hardly ever modifying anything unless I'm actually modifying some existing behavior. In fact, if anyone went to Sandro's chat yesterday about OO and that kind of thing, this is kind of like what he was talking about, coupling and cohesion and how much are you changing a single method. If you're always changing a test method, something's wrong with it. So don't test the things that can't break, just stop doing that. Don't test the things that don't matter, stop doing that. let the runtime handle your boilerplate, less typing again, and focus your tests on some real discrete behavior. So, isolation. I have a funny story about this one. Sorry, I'll just take some water. So I used to work at a company in the mid last decade, like 2005, 2006. And we had a lot of unit tests. And I had to add a feature. And I've been very, very diligent, checked out the code, run the unit tests, and to my surprise, this popped up on my screen. A Word document, save dialog, and my test suite had actually launched Word, done some stuff, and asked me to save a document. Now, we're talking 8, 9 years ago now. People have got really, really good at this now, so for the purpose of this, I'm going to assume most people are now aware of what a unit test really is. You may be dragging in a bit more than you need to, but we're not doing silly things like this anymore. And kind of like the rest of this, I want to use like a bit of more of an example thing. So let's pretend we're writing a game that involves a dice. There's a dice, if anyone doesn't know what a dice is. Now, dice. Dice is simple, but when you write dice in a system, you can use a random number generator. Which is fine. But the thing about random number generators, obviously, is they're very random. So you can't really use them in tests accurately. So what we generally find is most people's go-to place is straight away from using a real object to a mock. We've got an example of a JMock example there. Is anybody not aware of mocking? Awesome. Right, I'm not even going to explain this then. That's great. Repeatable tests, we've got them fully under control, all that kind of stuff. But a lot of people don't stop and ask themselves, do they need a mock? Mocks can end up making your code very brittle. So what mocks do is they tie what your code's doing directly into your test. And for if I'm writing a test here, do I really care how my code interacts with the dice? Well, actually, really what I want is I want a dice roll to happen, and that's it. So there are a couple of other techniques you can use instead of mocks. And the first one is stubs. Now, what stubs do is you basically implement your object and have it return a canned value. It's like this. I've got a dice, always rolls 5. Doesn't matter how many times I call it, which way I interact, it's going to give me 5. Now, these are kind of cool because these are really easy to knock up and stuff. But they're a little bit limited. Generally find these useful for, I want something that always throws an exception. Or if maybe I'm interacting with a database or something and I just want no data to come back. But you can't do a lot with them. So what you can do instead is write a fake. Take an example of a fake. And what this does is you seed this with a list of numbers that you want, and every time we roll it, we pop one off the top. Now, these are really, really cool, and not a lot of people actually use them. But you can get some really nice behavior without messing with mocking frameworks. But the thing about these is these shouldn't get complicated. If you're ever in a situation where you're thinking, I need to start testing my fakes independently, you've probably gone too far and you do need a mock. So let's see a little side-by-side example. So now we've got a test that needs a dice rolled 3 times. So on the left, we've got the mocking. On the right, we've got it with our new fake one. Now, I mean, there's no question there is, on the right, this is much, much more concise code. But not only that, you're using your dice in multiple tests. This is now reusable among all of your tests. On the left, this is not. You're copying and pasting this around. But on the right, you're just reusing your object. And they're really good for adding like default behavior as well. We actually use them quite a lot, I'm going to get onto that a bit later. Oh, actually, I'm getting onto that now. Awesome. So, where do you use a mock, where do you use fake, where do you use a stub? There aren't really any hard and fast rules on this. There are kind of a couple of guidelines. Steve Freeman says, like, you always mock things that change the world. And what he means by that is, essentially, anything that's going to change your system in some way. You want to know that has happened. And my corollary to that is, actually, everything else I don't actually care about. So we'll use an example here. So you can tell on my very classy t-shirt AIs work at Shazam. And one thing you can do in our app is you can log in with Facebook. And you can see what your friends are up to. Usual social networking stuff. So anyone that's worked with Facebook probably knows when you log into Facebook, you get an access token. You send that to Facebook, and they basically give you some data back about the user, and we store that in our system. So somewhere we've got something that fetches the data from Facebook and stores it. Because when I say Facebook and database, these are obviously interfaces, nice clean code, unit tests are isolated. But what I would do here is think about what is my important interaction. Is talking to Facebook important or not? So actually what I do here is, talking to Facebook is not important. That has to happen purely because of the fact we're going to get the data from there, but I don't care that that's happened. The only thing I really cared about is the data it gave back, I stuck that in a database somewhere. That's the important interaction. And certainly in a test is, if you've got two mocks and they're both doing strict validation, you've definitely got something wrong because you're checking two pieces of behavior at any time. And you should always focus on one piece of behavior. So let's look at the inverse there then. So you're signed in, you're away, listening to music and going, hey, what's that? Cool. So what we can do is, we can let all your friends on Facebook know that you're listening to Rihanna or whatever's not very popular right now. So this is kind of different things. And now what we're doing is we're talking about, we get our data out of the database and we send that to Facebook. So what's important there is getting information to Facebook. So we will flip that relationship around now. Because the database here is, I don't care what happened from that collaborator. That was just, you're there, I need you to be there, my class is going to use you, but what you do is very, very unimportant. What I really care about is, I send that piece of information to Facebook. So I'll just take a break. Now the other problem with mocks is, I find this most devs, like you discover mocking frameworks and then you just like use them absolutely everywhere. And you start mocking way too much. I was guilty of this many, many years ago. Just mocks, fantastic. But what you don't do is don't mock things you don't own, like ever. This is an example I got off the net of someone doing Makito, mocking a buffered reader. You don't own the buffered reader, don't do it. This is a perfect example where you can use, it's kind of a fake, you just inject a real object into there and let it happen. And the reason you don't want to do that is, I don't really care how my code on the test interacts with a buffered reader. That is not what's important. What's important is, I got my data out of it. I'm tying in the top part here, I'm tying myself very much into is, I'm going to call readline twice. Now, if there was some other way to get my data out of a buffered reader, I just want to call one byte at once and do it myself. That's valid, I can do that, but my test will break. And what you find is, when you're mocking at this kind of level, is you spend a lot of time, you refactor your production code, make it nicer, better, maybe performant, and all your tests are breaking all the time. And you don't want your test to break, because you really don't care what's gone on there. The biggest culprit I see for this is people doing JDBC. Don't kind of read the code behind there. It's really horrible, very, very complicated. This is all mocking stuff just to read one row from a database and get two values out of it. There is so many questions on Stack Overflow about how to do this, and the answer is always just do not do this. This doesn't actually work either. Didn't actually run it, but I'm fairly sure you can call a few things out of sequence and the test will still pass. But let's say you've done this and it all passes. What if my SQL is wrong in here though? Like my tests and my production code both say, yeah, the tests all pass, that's all fine. When it goes to prod though, it breaks because we were making some assumptions about what was going on. Or I rip this out, I replace it with Spring template or JPA, I don't know, I haven't done relational things for a long time, whatever's cool now. Your tests are all breaking again, but you don't care. All that your test cared about was, you got me some data out. So when you're doing things like this, is think, I'm not actually writing a unit test anymore, am I? I'm writing an integration test. Spin up an in-memory database, hit a real database, whatever you need to do, round trip your actual data. Not everything needs to be unit tested. The insides of your system are unit tested. The bits that talk to the outside world, they are integration tested. Treat them as such. So a little quick summary there is, so isolate your classes, mock things that change the world, fake everything else. Never, ever, ever mock anything you don't own. I have ignored my own advice on that many times and it's always bitten me. and realized that sometimes I want integration tests, not unit tests. So the final section, duplication. I think Martin's helped me here today because he's been talking about FizzBuzz and, yesterday he was talking about FizzBuzz challenge, so I don't need to explain FizzBuzz. There was a quick example of FizzBuzz. So this is like a really popular interview question. And it's like everybody knows how to do FizzBuzz. And everyone knows how to write tests for FizzBuzz. Fortunately, what I see is a lot of this. So this is almost taken from someone who interviewed with me. So we loop over the numbers 1 to 100, and then we do an assertion on checking them. There's a bit of a problem here, though. I don't know if anyone spotted it is. The 3 and 5 branch never gets hit in my test. Because the 3 branch and the 5 branch is going to hit it first. So my test is invalid. So I can implement my production code, make it pass the test. Way, my production code's actually broken. Again, don't know. What we're doing here is we're duplicating the logic between the production code and the test code. That's something you never, ever want to do. So remember, many years ago, I was at university, and we used to write test plans by hand. We used to pre-calculate all the values, and you'd have a little column with expected inputs, expected outputs. Did it pass or fail? That's what you should be doing here, is always pre-calculating what your actual values are. And again, going back to test naming, test diagnostics, you're not going to get no good diagnostics out of this, because you're never going to execute every single thing. So how would we fix this? Again, break it out. Stick it into 3 things. You don't need to cover every single scenario of that thing. Like, you don't need to loop over every single number and check them. You need to pick the interesting cases and get good diagnostics from them. Because on the same production code, this is going to tell me that the 3 and 15 branch is broken, but the 3 and 5 branches are fine. In fact, one thing I always try and aim for is no ifs, no looping, nothing in my tests ever. Psychomatic complexity of 1 and 1 only. If you're doing anything else, you're duplicating your production logic. So when we're all a lot younger and we're learning how to program, we always get drilled into is, I will not duplicate any code, ever. What you do want to do, though, is kind of duplicate the concepts between your production code and your tests. Just don't actually be copying and pasting code around, because that's a really, really bad thing to do. But you see a lot of duplication within tests as well. I would argue this is more problematic than duplication in your production code, because you've got a class in your production code and it gets called from 1 or 2 places. But your test code, you're calling that from that's been called in your production code so many times because you've got so many different scenarios. So what do? Let's go back to our dice. So now we've got 3 tests. And you only did a dice roll of 1. So we rip this out and we put it in our before method. I think most people are generally aware of this concept. Just get ignored quite a little bit, though. The rule here is, any line of code that's duplicated in a test, you stick in the before block. But what happens when we now need another test and it doesn't want a dice roll of 1? Typical thing, put another test in, instantiate the new dice. Doesn't seem so bad here. I can see Trish giggling there. So you duplicate your setup. Here you think, this is not too bad, because it's only 1 line. Only 1 line. But your tests are never this simple. Tests have got a complicated setup. And then you add another one, and you've got another bit of setup, and another one, and another bit of setup. And what I typically see a lot of is, you've got like 3 or 4 or 5 tests, they share the common setup, and then a whole bunch of other tests who just go off and do what they want. That's not cohesive behavior. We all know coupling and cohesion. That's not cohesive. I mean, typically this is kind of a very contrived example, but the usual thing would be like, I've got a mock. Everyone loves mocks. So I've got a mock, and it does certain things for some tests, but then on another test, it throws an exception, because I'm testing my failure cases. So pull them out in separate classes. Like, it seems like swearing in the JUnit community or something. I know Rob agrees with me on this one. But if you're testing 2 different bits of behavior, stick them in 2 separate test classes. Now, when your test classes are focused, your naming is on the actions, this makes this a lot more palatable than it's focused on the class name. So here I've got those ones needing a roll of 1, they're over there in their own thing. The ones needing 4, they're all over here. If you like want to do some inheritance and things to do the rest of it, on your own head, be that one. So, but we can't always do this. So with our dice example again, we're going to look at, we need a different dice roll for every single test. So you see this. And everyone in here said they do mocking, so I'm sure everybody is fully aware of doing this. I will set it up in every single test. This is duplication. I mean, you ignore, I think your eyes glaze over the boilerplate a bit and go, doing something different every time. It's not duplication. It is. So pull this out. Stick it into a method. Extract your stuff out there. This is like a couple of benefits as well. So the first one is, so your tests now say a dice will roll this number. This is awesome because your tests are now focused on what it is I'm trying to do, not how I'm actually trying to do it. Because this tells you I'm doing something with mocks. This tells you I want something that's going to roll a dice for me. What was the second thing that was cool about that? Yes, I remember. So we talked about stubs, fakes, and all that kind of stuff. I catch this early enough, and generally early enough for this is, actually I've done it once. I'll stick into a method because it reads nicer. I can switch between a stub, a fake, a mock, a will now, and I'm only changing it in one place, not a few dozen places. And who doesn't want their life to be easier? So this is like, oh, we're doing really well for time. So this is like the last section now. This is like a real special case of duplication. So at some point, you're writing some tests and you've got two objects and you want to know they're the same. Everybody's ended up doing this at some time or another. And what do? We use assert equals. I'm sure everybody's seen this. Look at our diagnostics. Our diagnostics are absolutely rubbish. We have no idea what's going on. Debugger, print statements, we're all over it. This is just terrible. This is terrible. But everyone does it. And then you make it pass by doing this. You go into your IDE and you say, generate my equals and hashcode methods. And your test passes. Fantastic. Whee, we're moving on. There's a really, really subtle problem with doing this. So we've wrote this now, say, I've got a name, I've got an occupation, they must all be the same. But some point down the line, some pointy-haired boss comes up and they give you a requirement that that equals method now has to have some business value. So let's say we've got an ID in this field. Your equals method is now based on ID, not all your fields. So you quite happily go off and make the change. This test still passes, obviously. But the thing this is testing can now break. All it needs is one field now. You change any of the other fields, this test is going to happily carry on passing. To me, unacceptable, that one. So try it. It's really hard not to, but don't do that. So you've got the diagnostics, subtle bugs coming up. So how do we get around that? So we use Hamcrest again. And Hamcrest's got a nice built-in feature, which is take two objects, tell me they're the same. So here we go, example there. So not only is this just awesome, but we've got some really good diagnostics straight away. It's saying, no, you're telling me the occupation is first mate. So that's a really, really good thing there. But this works really well for objects that only have fields, and they're not very deep objects at all. So for this example, let's change our occupation from being a string to being a real object. So back in the same problem we had before, is our occupation object now is giving us rubbish diagnostics again. And that now needs the equals method being overridden so it can work its way down your tree. And this gets worse and worse and worse. You can do a few things to get around this. And this is like a problem we've faced quite a lot. We write our own custom matches for this. And so you start putting them together and then they get very, very complicated. And then you spend so much time writing matches and everyone gets sick of writing the matches all the time. And then a change in one place just ripples through your system. So what we did is we got bored of doing this. And we wrote our own match, which was same bean as. Now, it's a little bit contentious. But what we essentially did here was take two objects and serialize them to JSON. Performance, not a problem here. It's test code. Don't really care. So we turn them into JSON. Make sure they use the same thing all the time. Ignore annotations, do exactly the same thing. But now what we've got is full deep object checking going on here. You can make your object graphs as big as you want. This automatically works. And what it's telling us here is, our path at occupation.job title should have been this, but we got this. Now, this is really nice diagnostics now. In fact, after we wrote this, we just ripped a whole load of custom matches out of our code. Negative line commits all the way. Fantastic. And for those that are really paying attention, you can see at the bottom there, it says click to see the difference. Because we're doing JSON, this is good. We've got strings to work with. So in your IDE, you can pop this up. And this is like really nice now. It's before and after what exactly went on. And, everyone can read JSON. It seems a bit weird. But it's really, really good for digging in exactly what went wrong. And you can download this. This is open sourced. You can find Shazam, GitHub stuff. You can go and find this. Kind of early alpha thing, so it may not work in every scenario. So, don't duplicate logic into your tests. And don't duplicate logic within your tests. Don't override equals and hash codes purely for your tests. Refactor your code mercilessly and use Hamcrest. The refactoring point really is your test code should be treated the same way as your production code. Your tests need your love. Don't treat them as second-class citizens. Treat them as first-class citizens, and they will treat you well. So what to do next? You can follow my blog. I'm going to put this on there with much better code examples. If no one's read this book, go out into the atrium, buy this book. It will change your life. I have nothing to do with this book. It's just fantastic. And if you love testing and you really want to see how far you can push it, come and talk to me and see if you want to come and work for us. We're hiring like server people and Android people, web people, the whole thing. Thank you. So we've actually got a bit of time for... Oh, straight in. Yes.
The idea of having an abstract test, you're testing different concrete implementation of the same interface. Say I wanted to make sure that linked list was the same as an array list. Wouldn't that be a case where an abstract test might be right, and then you inherit it and create concrete implementation?
You could. Good question. To be honest, never something that's really come up that much. Oh, sorry. So the question was, would you use an abstract class for testing multiple implementations of the same interface? And so there are some documentation you get online about this. You could use a parameterized test runner, will do this for you. Or if you start using Spock, that's got much better support for that stuff. But generally, I just find this something that doesn't come up that much, generally. That's the best answer, sorry. That's such a cop-out answer. Inheritance is bad. Everyone knows inheritance is bad, surely? Inheritance is always bad. Any more questions? Awesome, thank you.